As we move on to the next portion of the sample test multiple choice, now we're in numbers 29 through 37. We're looking at the calculator portion. So I have my calculator, hopefully you have yours too. Which definite interval represents the volume of a sphere with radius 2? We've got a couple of things going on here. The first thing to really consider is that we have an x and y axis with a function that's a spherical kind of shape. So I'm thinking something that looks kind of like this, and then we're going to rotate it. So we're going to take that and we're going to rotate it this way. Now, I can make this on both sides here. So we're going to take that, we rotate it using a bunch of discs, and this will spin and rotate into a ball. Well, it's helpful to know that this curve here, the semicircle, is equal to the square root of 4 minus x squared. How do I know that? Because if it's a circle, that starts out as x squared plus y squared equals 4, or 2 squared, because I know that the radius equals 2. And then if I simplify that, I get y squared equals 4 minus x squared. And then if I take that a little bit further and I square root both sides, I get y equals square root of 4 minus x squared. Then I'm going to rotate that. And I know this goes out to negative 2 and up to 2. So if I do the integral of pi big R squared from negative 2 to 2, that should give me my sphere. So if I were to substitute this piece in, I got a pi on the outside from negative 2 to 2, and we got big R squared is going to be 4 minus x squared, because the squared and the square root are going to cancel each other out. Do I have anything that looks like this? Well, we got 4 minus x squared times pi from 0 to 2. That's not right. We got x squared minus 4 from negative 2 to 2 times pi. That's kind of backwards there, so that's not really going to work for me. Then we have here 4 minus x squared from negative 2 to 2 times 2 pi. Well, that must be out too. And it can't be plus, it needs to be minus. So it must be this one. Well, this is kind of weird. Notice that this is symmetrical, meaning that the left side is equal to the right side. So what they're doing is they're just doing half of it and then multiplying it times 2. And that'll give them the whole piece. So that's where this 2 came from. And they're only starting at 0. So it must be C. Number 29. The particle moves along the x-axis. So its position at any time is given by x of t. So we're given position. It's saying for which value of t is speed. Speed, 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 speed. Notice that speed equals the absolute value of velocity of t, which in this case is the absolute value of x prime of t. Well, let's figure out what x prime would be. X prime of t is going to equal 4t cubed minus 30t squared plus 29 times 2. What's that? That's 58. 58 t to the first power minus 36. So let's figure that over the interval around t from 1 to 5. So I'm going to graph that. So I go to my y equals here, and how am I going to do this? Let's do this. We're going to shrink this. I didn't know I could do that. Cool. I can actually copy and paste the picture. All right. Going back to what I was looking at here. We clear this. We're going to have 4t, or in this case x, to the third power minus 30t, or x, squared plus 58t, I think it said minus 36. Let's double check. Is that what we got? Yes, that's what we got. So, knowing that, I want to go ahead and graph this and see what it looks like. Graph. Now, the interesting thing here to remember, you guys, is we're looking at the values 1, 2, 3, 4, and 5. So I really just need a table that's going from 1 through 5 and see what's biggest. Oh, by the way, I'm doing speed, which really means I need absolute value of this. So I'm going to do absolute value. I'm going to insert that. So I do second, delete. That allows me to insert something. Absolute value is in the math menu, so I click on math. Then I go over to num, and then there's absolute value. So I'm doing absolute value of this whole thing. So let's wrap it up with a closed parentheses. So now we graph it, and we're trying to look at where's this greatest term. Well, it definitely looks like somewhere around here, like 4 or 5. So let's change our window here. Let's go from 0 to 5. And then for the y minimum, we know it's not going to be less than 0. Let's go up as big as 100, and we'll do a y scale of 10, just so we don't have marks all over the place. Looks like it's clearly right about here. It's hard really to tell between 4 or 5, but there's a way to tell. You just plug in the values. So we got 1, 2, 3, 4, 5. Actually be between 3 or 4. So let's plug in 3. So if I do trace and I type in 3, it's going to tell me that that y value is 24. And if I do trace and I type in 4, it says y equals 28, slightly more. And what's this way over here? If I were to type in 0, no, that's not one of my options, because if I type in 1, I'm down here, 2, I'm down here, 5, I'm down here. So it looks like the answer is 4. Does a particle with velocity at any time t given by v of t, blah, moves in a straight line? How far does the particle travel during the time interval when its velocity increases from 2 to 4? Okay, so I'm looking at when does v of t equal 2, and when does v of t equal 4? And it's asking me how far does it travel over that time. So t equals something here, and t equals something here. And those are going to be my limits here. So t equals, we'll call this part a, and t equals b here. So t equals a to b. And then we're going to take the distance traveled, which is the absolute value of velocity. So I need to figure out what a and b are. Well, if 2 equals 2e to the 2t, then that means 1 equals e to the 2t. If I take natural log of both sides, natural log of 1 equals e to the 2t. Or pardon me, natural log of e. So it means 0 equals 2t. So a equals 0. Over here, if 4 equals 2e to the 2t, then 2 equals 2e to the, or pardon me, 2 is gone. 2 equals e to the 2t if I divide both sides by 2. Then I take the natural log of both sides, natural log, natural log. The natural log of 2 equals 2t. So natural log of 2 over 2 equals t. So that's my b. That's natural log of 2 over 2. Or 1/2 of natural log of 2, or natural log of square root of 2. There's a lot of different ways to write that. We got this velocity. And so let's do that. So we need to plug in this function and evaluate it over this time. And that's not too bad. So I'm going to take this, I'm going to do a new function here. Clear this one. We're going to go e, which is second natural log, e to the 2t, but in this case we're using x. So there's our function. Look at that. So now we're going to go to second. We're going to calculate. We need to calculate the integral, which is 7. And the lower limit is 0. That one was easy. The upper limit, now we're going to type this in. It's natural log of 2. And we're going to divide that by 2. Looks like it's calculated. Did it already calculate it for me? Second, calculate. You know what, let's clear this. Let's trace. And I'm going to do natural log of 2. Then divide by 2 and see what that x value is. So it looks like I'm at 0.3465. 0.3465 is the x value, and the y value there is 2. So then if I were to integrate that, oh wait, this is interesting. They give me not decimal approximations. I should have been paying attention here. So I just need to do the absolute value, or I have to do the integral of 2e to the 2t from 0 to natural log of 2 over 2. So I have to do this one by hand. Wow. But they put it in the calculator section. I should be able to do this. All right. Well, this is e to the u du already, because the du of 2t is 2. And the integral of e to the u du is e to the u. So the integral of this is going to be e to the 2t. And we're going to evaluate it from 0 to natural log of 2, or 1/2 natural log of 2, I guess you could say. If I plug in 0, that's going to give me 1. So I'm going to have minus 1 on the left piece. Pardon me, that should just be minus 1. And then for the other part, we're going to have e to the 2 times 1/2 of natural log of 2. 2 and 1/2 reduce, e and natural log reduce, so this is just 2. So 2 minus 1 equals 1. Are we serious? Is it that easy? It is. The answer is A. That was easier by hand than calculator. It's kind of interesting. Lesson learned. Let f be the function whose derivative is given by this. How many relative maximum points does f of x have in the interval from 0 to 12? Oh, that's pretty easy. To know something's a max means that it was positive before, negative after. So we got to see when the derivative changes from the positive side to the negative side. Every time we see a line do this, we hit a max. Because if it's above, then below, then it's a max. Why am I thinking in terms of derivative? Because that's what I'm given. So I got to graph that and see what happens on the interval from 0 to 12. So I have the graph. Looked like it said x divided by 15 plus, and what do we have here? Sine. Wow, that's an embedded function there. Sine of e, which is this one here, e to the, oops, bring that back, e to the 0.2x, 0.2x. Close that off, close that off. And we're going from 0 to 12, so I'm going to change my window. I'm going to go from 0 to 12. Oh, my function's pretty low there. Let's change this window, the y values from like negative 10 to 10. So negative 10 down to 10. I'll do a scale of 1, just like usual. Okay, so it looks like it happens maybe once, twice, or once, twice. So I need to limit my y range here. So if I go back to window, I'm going to change my y range from negative 10 to 10 more. Looks like maybe negative, I don't know, negative 3 to 3 would be more appropriate. Yeah, it sure does. So it happens once and twice. Once here, just found out I can do this. This is so cool. So how many times does that happen? Well, it happens here and here. So twice. 2 maxes. Relative maxes, of course. 2 cars start at the same place at the same time. 1 car travels west at a constant velocity. So this one is, let's say, dw dt equals 50 miles per hour. And a second car travels south this way, 60 miles per hour. So we'll call this ds dt equals 60. Approximately how fast is the distance changing 1/2 hour later? So remember, these are in terms of time equals hours. So 1/2 hour later, that means t equals 1/2. Okay, well, I need to find a way to relate 3 sides of a right triangle. Well, I do know that. It's a squared plus b squared equals c squared. And another way of thinking of that is it's the distance squared equals southward travel squared plus westward travel squared. So I just need to take the derivative of this and multiply by my rates of change. So this is going to become 2w dw dt plus 2s ds dt, if I differentiate everything with respect to t, equals 2 times the distance times distance dt. And what we're really looking for here is this distance dt. Everything else I'm going to have to plug in. So I do need to figure out the distance. If this is 50 miles per hour, how far did they travel? Well, they traveled 25 miles because half an hour of travel at 50 miles an hour is 25. That means that this is also 30. So I got 25 and I got 30. Now those are kind of proportional. I could say this is 5 and this is 6. And I'm trying to figure out this distance here. Well, this distance is going to be the square root of 25 squared plus 30 squared. So that's going to be 900 plus, what would this be? 225, 625 plus 900, and we're taking the square root. This is my distance between them. And then if I were to add those two together, I'm going to have 1525. So I want to take the square root of that to find that distance. Then I'm going to plug everything in, divide it by 2 times that, and that should be my distance dt, or at least approximately. So 2w, how far was w? That was 25, we figured. And dw dt was 50. And how far was s? That was 60 divided by 2, that was 30. Traveled 30. And then ds dt was 60 miles an hour. And then over here we figure out the distance is about square root of 15, not about, it's exactly square root of 1525 times distance dt. And we're trying to figure out distance dt. So I'm going to divide these two numbers by 2 times square root of 1525 and see what I come up with. So I got 2 times 25, which is 50, times, so this, whoa, this is interesting, 50 squared plus 60 squared. Ooh, that's interesting. That is interesting. Because now I'm going to have 1525 over 2 times the square root of 1525, which is really square root of 1525 over 2 equals my distance with respect to time. There's some fancy math going on there, but trust me, it works. Okay, I got rid of this already. So I got 1525 divided by 2. Square root of 1525 divided by 2. So I'm going to clear this. I'm going to do square root, which is right here. Nope, that's x squared. We want to do second square root of 1525. Not 15.5, 1525. And then we want to divide that by 2. Let's see what we come out with. Doesn't look like anything they got there. What are we missing? Approximately how fast is distance changing between them at 1/2 hour later? We got 50 squared. Well, let's see if maybe we just need to figure it all out here. What's the distance between them? They look like they should work. Not sure. I'm going to have to come back and check on this one. Maybe we'll check on it in class, see if you guys can figure out something. But I know that it stems from the idea of a squared plus b squared equals c squared, and that's going to be 2a dA dt plus 2b ddt db dt equals 2c dc dt. And it's asking us dc dt. So it's going to be, however we figured out, 2a dA dt plus 2b dB dt over 2c So actually the 2's will reduce, and we'll have a dA dt plus b dB dt equals over c equals dc dt. And we know that a was 25 and b 25 and the rate was 50, and b was 30 miles and the rate was 60, and c is a squared plus b squared equals c squared. One half hour later should be that. Let's see if I just did some mental math inappropriately here and recalculate that. So we got 25 times 50, 25 times 50, 50 quarters is going to be 1250. Is that right? 25 times 50 is 1250. Okay, and then we got 60 times 30. I'm not really trusting myself right now. So we got 1250 plus 1800, 1800 plus 1250. So that's 3050. I do think I'm a little bit off here. So it's those things divided by the square root. Where's the square root? We got square root. Can't think. Oh, here we go. Second square root of, what was it, 1525? Yeah, 1525. This is what I get for trying to shortcut the math. 78. That looks more like it. D would have been the answer. You guys probably figured that out way before me. Good job. What number are we on here? Is this the last one before we move on? It is. All right, let's wrap it up here. As shown in the figure above, it's actually below down here. This is number 37. A square with vertices 0, is divided into two regions by the graph negative x squared plus 2x. If a point is picked at random from inside the square, what is the probability the point lies above the parabola? In other words, that's asking what's the probability that it's in here. And probability, this is kind of weird, probability in calculus, but probability equals the positive or yes or confirmed type answers over the total possibilities. So what we're looking at here is the area above over the total area. That's what we're really trying to find. Well, the total area is easy. The area of the square is 2 by 2, so that's just 4. But then we got to figure out what's this area above. And the area above is going to be the integral, or it's going to be this region here. And the area of that region is the integral from left to right of our boundaries of top minus bottom. Okay, so top minus bottom. The top is just an equation y equals 2, so that's 2 minus. And then the bottom is going to be negative x squared plus 2x. And we're going to integrate this from 0 to 2. Now, I could do this by hand, but I don't really need to. Why? Because I have a calculator. So let's use my calculator. I pull this up here. So I'm going to go to y equals. I'm going to clear out that one, and I'm going to type in a new function, this time the one that I need. 2 minus, and then parentheses, I'm going to have x squared, or negative x squared, pardon me, negative x squared, and we got minus 2x. I'm pretty sure that's what we have, but just to double check, like we always like to, oh, it's plus 2x, plus 2x. Is that true? Negative x squared, yeah, that would be true, plus 2x. So this should be a plus right here. All right, so we got plus 2x. That's our function. Now we just need to integrate that from 0 to 2, so in this little area here. So let's fix this window. We're going from 0 to 2, and the y range actually seemed kind of appropriate. So we need to integrate that. So second, calculate the integral. Our left boundary is 0, our upper boundary is 2, and the area equals 2.66666667, or 2 2/3. So this equals 2 2/3, or 6 8/3. So it's 8/3 is this over 2 of the whole thing, which if I were to flip this around and multiply, it's really 8 over 6. That does not make sense. Oh wait, the whole area is not 2. The whole area is 4. So this is 8/3 over 4. So when I flip and multiply that times this by 1/4, it's going to become, let's see if we can simplify here. 2 on top, 1 on bottom. It's really 2/3. That's kind of interesting. Simple answer. 2/3. E was our answer. You could probably have reasoned that just by looking at the picture, but that's a pretty cool problem there. Alright, that's it for this video.